you'll notice very quickly that the first thing that it did is that it stopped.
Hello?
Hello? Hello?
Hello?
Can you guys hear me?
I can hear you. Hello.
Hello.
Okay. There's three of us.
Okay, so that's good.
Can you guys hear me?
I can hear you.
Yep.
That's 4. Can you guys hear me is the question. Hello? Can you guys hear me?
Okay, so Ram lost his internet connection, I guess.
Oh, great.
Oh. Yeah. That'd do it, wouldn't it?
I'm just guessing. I mean, it's affecting everybody, and we can't hear him.
All right, give me a
We can all
second.
hear each other.
Let me try this again. Can you guys hear me?
Okay, maybe a Hangouts host problem then. I mean, on their servers. I don't know.
Yeah, maybe. That is weird, though.
Hold on one second.
First time I've ever had anything like that. What happened?
Can you guys hear me?
Yes.
Oh, yes. Now we can.
What the hell just
We're all
happened?
back.
Okay.
Well, we all got disconnected.
So I just restarted the stream
Yeah.
because I thought it was an issue with the
We
stream.
were pretty quick into it.
Huh?
I said, yeah, we missed everything up to when you started evaluating that loop.
Okay. Well, it's good because I restarted the stream because I thought it might have been an issue with the stream. So I'll just go ahead and revisit the what we were talking about. Roughly today, there is. I was just going to mention, Elijah, that today we're going to be discussing sort of some edge cases with loop, some of its disadvantages, and then we're going to talk about 2 specific libraries. One I'm somewhat familiar with, the Iterate library, and I know that Michael last week mentioned the 4 library that Shinmera wrote. So we'll be discussing that. But there was a question regarding when would one have parallel 4s in a loop, and how does one why would you have a situation where you would want the stopping condition to be the value of the shortest collection? And I gave an example of like, let's say that you are providing displaying indices for a collection, right? So one way you could do it is you could have a collection that
I can't see your screen.
Can you not?
By the way,
can you not see my screen? Okay, give me a second. But
I can't anyway. Can anybody else?
Yeah,
no,
I think.
All I see is a circle talking.
Yeah. Okay, give me a second here. I'm going to try this one more time. Okay. Can you guys see my screen?
Yes. Yes, much better.
All right. Back to what I was saying. So, for example, let's say that we have a collection, a vector. Okay. It doesn't matter if it's a vector or less. I used a vector just for the sake of example, of 20 integers, and we want to iterate through that vector and grab its index and its value. So one way of doing it, if you're using loop, is, because as far as I know, loop doesn't give you the ability to grab the index within a particular vector. But one way to...
Loop doesn't, no.
One way to simulate that, though, is do loop for IDX up from 0, use an infinite iota to keep incrementing itself, and then iterate through the finite collection as well here, as you can see here, and just, do whatever execution you want. In this case, we're going to print it out. And when you when you execute this guy, you'll see that although IDX represents an infinite collection that keeps generating, the loop will terminate because the finite collection actually determined when execution will stop. Now, if we were working through multiple collections, which is what I was saying before we ended up cutting off in this conversation, in that case, like let's say that we have this test list here, and let's replace this with from test list to test vector. Can you guys still hear me? This is where people got cut off.
Yes.
All right. Just got to make sure now. When we iterate this, execute this guy again, we'll see that test list actually determined when this loop will terminate, not test vector, because test list is shorter than test vector. It's less, and loop figured that out and recognized, okay, as soon as this collection is done, I'm completing it. So this is one situation where I see having multiple fors that are independent of each other very useful. Outside of that, I don't know. I mean, maybe when you're doing aggregation and you have different collections from, like, say, different data sources that you want to aggregate, instead of having,
Yeah, like if you have a bunch of vectors that are indexed in parallel, for example, you could loop over all of them simultaneously.
Another example would be like if you were looping over a list of class instances, and say you wanted a second for to grab a particular accessor out of that instance, then you could do it like that. Because they're mutually recursive. Like you could reference the previous in the next.
Wait a second, though. I thought doing the parallel for in this case, it doesn't actually allow you to grab the previous value. It actually messes with the increment, right?
So if you use a for equals then you have then you can access the previous value.
So if you look at one example I wrote from last week, and I can show this here. If you just simply change for computing like Fibonacci numbers, right, in a sequence,
right?
Here, if I change this to a for, all right, instead of an and, it will actually compute the wrong thing. Right. So if we run this guy, you'll see if we do compute 5 sequence just for the first 5 numbers, it actually produces powers of 2, not actually.
Right. That because it's updating them sequentially.
Right. It's updating them sequentially. Exactly. So it's doing it one after the other.
It's seeing the more recent value of x.
Exactly, and that's not what you may want in certain situations, right? Like,
right.
Okay. So that's what I thought you're saying about your previous comment. Does that like in some cases?
Yeah, it's related to that.
Yeah.
I mean, I don't know. You can do all kinds of craziness with loop. It's a bit of a crazy macro.
It is certainly one of the more interesting features of Lisp that I've stumbled on. And you can keep going with it. Like some example that I had along with the infinite sequence that we were talking about is one overarching example I always had was, just printing out, the values of 10, right? So I came up with at least 8 different ways, and I found a 9th one just, while I was playing around with it, which is if we did 4x up from 0 and then do a wit with a dummy collection. All we did is
oh dear,
do an until, greater the length of the collection is 10. Then all you'd have to do is just do a push X into the collection. Well, you could do a print here first, and then push it into the collection, and not return the collection here like I would, and it'll do the same thing.
You could also do a collecting into.
Right, you could do also a collecting into, which is kind of crazy, but you don't want to do that in this case, right? Oh wait, you do. You may be able to do that. Hold on, let's see if we could do that.
And remove the with call equals list.
Yeah.
But this guy will be. Would this work though? Oh, it did. Interesting.
Yeah.
The reason I wasn't sure is would call get initialized for this until
Oh yeah, all the
terminated.
loop variables are created before any of the forms are processed, and they're initialized with some dummy value, probably nil, if it's a list.
Interesting, because I wasn't sure about that, so I was like, okay, let me try this out. Okay, so there's multiple ways of doing this, and it's just insane, just how versatile this macro really is.
No, iterate kind of blows it out of the water. Iterate and for both, to be honest.
So my experience with Iterate has been using it for sort of the same use cases as with loop. So I can't say that I really used full power, though I've been playing around with and that's what we'll show today. My iterate code. I used it for the same examples, roughly. One of the nice things about iterate that I liked was, the fact that I can get indexes. And I used, and as well as the syntax for reading files is a little bit easier to do, and I gave those examples. But there's a lot of features here, folks, that I haven't actually touched. Well, touched in the sense that I haven't given sufficient examples, like for streams and extending iterate, which is probably the biggest feature that I wanted us to discuss through. The differences, especially when you start talking about implementing extensions to iterate versus implementing extensions to for, because I can't really see a difference between those two libraries in terms of...
There are a couple of pretty significant differences between iterate and for, which we'll be happy to get into if we want to go down that road.
Right at the top of the for README, there's actually a differences between loop and iterate.
Well, it says that it talks about code walking versus I'm forgetting what was the other one. It was code walking versus it does not require code walking and it's easier to extend, but code walking is because iterate macro expands until it and then rewrites certain things before it
so iterate lets you stick iterate clauses inside arbitrary subforms.
Right.
Which for does not do, in short. Because in order to accomplish that, you need a code walker. And
additionally, for, there's a couple of pieces of code that I thought would map exactly from loop into for, and it didn't. Like collecting, let's say that you want to do numerical iteration, you want to just do a range.
Yeah.
It didn't have a to. It has a from, but it has no to. So I couldn't actually write, an exact one-to-one of that. There's a ranging inside iterate that one could leverage, but it isn't exactly one-to-one, right? So one example that I could show you guys is let's say for would not have, that's right, I didn't actually load for. So for, and then you could do ranging I from 0 to 10. And I have to actually, obviously do this. Ranging I from 0 to 10. And I wasn't sure if I had to collect here as well, if that works or not, because it says that I is unbound when I try doing this example. So just a couple of things that, as we go through and talk about for, I want to at least mention that there isn't a couple of things that map one-to-one exactly from loop to the new for library, because it looks like it's a couple years old actually, versus iterate, which is I heard about iterate a long time ago, and I looked it up.
Yeah, iterate's pretty ancient. It's been resurrected a couple times.
It's about 10 years roughly. I heard about it from a while back, and I played on and off it over years, which is why I use it for most common situations, but I've never had an opportunity to ever extend it. So let's just talk about, first off, the disadvantages. So the two disadvantages that I know about the loop macro, right, is extensibility is number one, right? And and I don't know if this is necessarily a bad thing, but a lot of pure Lispers say it's not Lispy enough, which means it needs to require some extra parsing. And I'm like, okay, yeah, from one standpoint, it certainly makes it look not like Lisp, but it does provide a lot of functionality. I think the extensibility problem is much bigger than it being not Lispy enough.
With that argument, you should probably remove those 4 format lines on your screen then.
Yeah.
Because that's by far not Lispy.
Oh, the 4, yeah. Yeah, you're talking. I'm a big fan of format. I'm not gonna lie.
Format is awesome.
I don't know why. Format gets a bum rap for some reason.
Well, it's really hard to read complicated format strings with a lot of practice.
Yes, it takes a lot of practice, absolutely. But once you start, it's kind of like if you use printf, or any format
but printf can't do looping.
Yeah, true. Well, I think with newer JavaScript string interpolation, you can do looping inside.
Sure.
So, and it looks uglier. And
yes, but those printfs don't have case conversion or pretty printing blocks or
format allows you to define new. Directives.
Right.
Do they have Roman numerals?
Yes, actually.
Oh. How about conditional plurals?
Yes.
Oh. Wait, we're talking about printf.
Format. No, sorry.
Format has it.
Sorry, other way around.
Okay.
Sorry, I was mishearing you. No, printf does not have either of those things, and you're right.
Printf does not have either of those things. It's a very dumb string formatting utility. But that said,
it gets the job done.
It gets the job done, exactly. That's and you can always write a loop yourself. There's no reason why printf needs a loop.
You do feel cleverer when you manage to get it all into a single format string.
Right, exactly. If you can do it, hats off to you. But you may have just created a piece of code that only a small number of individuals will actually truly understand.
A small number of Lispers.
Yes. Absolutely. So that's the reason why I say...
have a question about iterate.
Yeah, sure.
Sure.
I personally have very limited experience with it. I've only used it once or twice. But I was wondering, how does it do with regard... does it expand to efficient code like loop?
Actually,
decently. It expands to about as efficient code as 4 can. It has an eye on efficiency, I suppose you could say. Neither 4 nor iterate are ever going to be quite as fast as loop because a lot of implementations use a lot of funky trickery to make optimizing loop, easier for them. So there's always going to be a little bit of a lag time between any non-implementation provided iteration macro, but nothing serious. The overhead's pretty tiny, and iterate generates some reasonably optimized code. I've looked at it a good bit.
Okay.
It's much better. I know iterate is good enough. For most common situations, I haven't hit a case where, one case that I saw was, like I said, I was using it mainly because I used to write my reading a file like this, all right? Where basically I open up a file and I loop it and I hit until a thing and then I execute it, right? This is pretty much standard. Cleaner. That's... Yeah. You can look at it and you can say, okay, I'm reading lines by just looking at the form, and you're not, and it does a lot of the stuff behind the scenes. Yeah, it's a little bit more, abstracted away, and you certainly do.
I'm pretty sure that generates pretty much the exact same code.
I'm almost certain it does. We could probably do a disassembly. just look at the instructions that are being generated once it gets compiled.
Yeah,
if you really
I
wanted to.
just step through the macro expansion
Yeah.
personally, but yeah.
Well,
Either way.
each his own. My point is, I mean, the iterate code, anybody can read and realize, okay, I could change this to just read, and it will do a different type of read, much like I could change this to read, and it will read through and parse through, and they'll do exactly the same thing. In fact, by default, iterate for reading files will use read to read in S expressions. It just assumes that you're trying to read in an S expression from a file. That's the default it uses.
And shouldn't that be what we're all using anyway?
Right. I hope one day.
Sorry.
Not today. One day, but not today. So, iterate. One of the main features that from the example that we were talking about earlier about using infinite sequences that I thought Iterate had built in is these features for like indexing and going through the index of individual collections that you're passing through. So like in this example here, I have a sequence that I created of even numbers. Oh, sorry, I forgot. I have to load the library first.
Would help.
So when I run this guy, I have a list of even numbers up to 10, which is, and as you can see, if we print out using index of sequence, it'll go through and actually go through one at a time, grab the index, grab the value, and then print it out. One thing you may notice, folks, is I'm using index of sequence and not index of list. And that's because if you want specific indexing of list, one doesn't actually exist in the iterate library, as far as I can tell. If you want the index of a list, you have to use index of sequence and pretend that it's a sequence library. To iterate through the list, you can use in or on, like you did previously in loop, but not grabbing the indexes of the actual list itself. So this is actually equivalent to earlier. So again, just like loop, iterate itself has a library, provides in vector, in string, sequence types to actually provide enough type information to do certain optimizations for those types, much like loop does for having a separate, like a cross keyword to iterate through vectors versus in and on to iterate through strings and lists. Another
is
nice.
Iter the same as iterate there? I see you have two different.
Say that again.
You have 3 iterate : iters, and then after that you have iterate : iterate. Is
Yes.
And
that the same
actually,
thing?
the iterate package is also nicknamed iter, so you can use iter.
Okay, I was just wondering if there's a difference there.
Yeah, I wanted to show that too. Yeah, you can use either iterate : iterate or iter, or has Elijah iter : iter to actually go and reference the exported symbol iterate. I prefer iterate : iter. Other folks might like iter : iter. It just doesn't look right. I know what the package is, but I wanted to show you iterate : iterate just so that you know that the exported symbol itself is called iterate too as well.
Yeah, my initial response was this is a lot of writing iterate, especially if you're embedding clauses into other like arbitrary functions.
True.
So, yeah.
You could,
rather than using package local nicknames, I think iter really helps with that.
Certainly, and I wanted to know if there's a way to actually do like shadowing a little bit if I'm leveraging iterate only to say, okay, within this package, most of the keywords are just going to go through iterate, so I could just do eventually like iter, just like in a lot of the examples that I've seen.
I mean, you could You could use the iterate package if you like.
It does. It does. If I do use package, it gives me a lot of name conflicts with some stuff with. I think it was
Right, because there are a lot of symbols in the iterate package.
Yeah, and I think it conflicts with almost all of loop, which is why I wanted to do, like, if I define a package and I do a shadowing, I could say, well, everything that's in here, just use this guy. Don't worry about loop.
Well, it wouldn't be an issue with loop because loop doesn't actually look at the symbols. It looks at the symbol names. And so if you create the package ahead of time and make it use iterate, you shouldn't see the package conflicts.
Okay, I'll try that. I think I may have done something stupid when I originally tried it out, but I was getting the same sort of package.
Yeah, if you use if you'd already done some loop stuff and then you did a use package iterate,
yeah,
you'd probably see a lot of conflicts. Yes, but if you did like a def package and inside that def package you used CL and iterate, you should be fine. There aren't any conflicts with that.
Okay.
It's just that once you start using loop, you're creating new symbols in your local package. If you aren't using like keywords for your loop, for your loop keywords, if you aren't using actual keyword symbols,
Mm-hmm.
then what you'll actually be doing is creating symbols in your local package that are named for the loop keywords.
Mm-hmm.
And then when you try and use the iterate package, those symbols will conflict with the symbols in iterate.
Gotcha. All right. That makes more sense then. In fact, we could probably even try that right now. Let's do a def package test. I'm just gonna call it no. arm.rv.demo. All right, and we do iterate CL and that, and let's just do an export of a demo function. So you're saying inside here. If I do the demo, so let's first define this guy and put that in. What did I mess up here?
Sorry, I missed that.
If I do in package.
The RV.
Oh yeah, sorry.
Yeah.
Dash. Okay, I'm an idiot. All right. Let me just do one thing. Go here. Change package to this guy. Okay. You're saying that in here I can now do iterate for. Let's take one of my examples.
Yep.
Yeah.
You already have the right LDoc, so it seems to be working.
It does. Okay, sweet. Okay, excellent. Let's do this. I did not realize that was what my mistake was. Let's just do this 210 by 2.
To be honest, I still tend not to include the whole iterate package in most of my stuff, just because it exports a lot of symbols, and you do tend to run into conflicts occasionally. But, it's a preference thing, and you can definitely maintain that however you like.
Certainly. In some cases, I agree with you, especially because I don't like doing navigation. I'd like to know what package something's in, so I actually do prefer package : exported symbol. But iterate is such a large nickname, right? I mean, it's such a large thing, and this alone kind of is not short enough for me. I need it to be even shorter than that, but that's why I use package open nicknames too in other cases. What else did I want to mention about iterate? Oh, this is another nice cool feature that I didn't realize until I was playing around with it a little bit more today in depth. But iterate actually provides you already a keyword in its package for grabbing the previous value. So if you needed the previous value in certain situations, it's already there by you providing a separate variable and use :previous and specify what value to binding.
Yeah, that's provided because, if I remember correctly, iterate simply doesn't provide a mechanism for parallel iteration.
Yes, it does not. It does not provide anything for parallel iteration, and that's something that is I don't know.
It
I don't know.
it cleans up a lot of the semantics, but at the same time, it means you have to introduce things like previous value.
So one thing that I wasn't sure about then is let's take this example that I was trying to do earlier, which was the Fibonacci example. I was trying to convert, what was it here? Compute Fibonacci essentially to be like to use iterate instead of loop. And one thing I wasn't sure about is how to convert the and, create the serial dependency. Yeah.
Well, there are a couple of ways you could do it. So probably the most straightforward would be to use the previous value of A when you're computing B, or previous value of X when computing Y, rather.
Okay, that's what but so would I do, let's say this, I guess it's going to be repeat n for X initially 0, then Y. For Y, it would be
initially 1.
Initially 1, and then do a previous X, or
you do then plus Y previous X, I think. I'm pretty sure that's right. I forget what the
colon.
I forget what the thing is.
Like this, or is it?
No. Well, I mean, you need to wrap that in a form.
Okay.
It needs to be in parens. I think you can just do prev X, if I remember correctly. I think that's the functional way, or the sort of function way to do it, if I remember correctly. But I could be wrong.
Okay.
We will see.
Yeah. Well, yeah. It's always good to try these things, right? So.
Yeah, it's been a little while since I've tried using iterate. It did not like your initially.
No.
Oh, because yeah, you misspelled one of them.
Yeah, that's one.
Yeah.
Okay.
And okay, so it's not prev, so it might be previous.
All right.
Or they might have removed that feature. I forget.
They
did. Okay.
So what I can do is I could do this. I think it's for
yeah, for
previous
prev previous X. Yeah.
And then
do Y plus prev.
Yeah. And then that should do it, but
yeah. So that's one way to pull it off.
But I'm not entirely satisfied with the approach, I'll be honest. I mean, it looks like we're essentially. This was such a nice feature of loop, right? Like you could do a sequential thing.
So
the manual says it's for var previous var.
Yeah, which is what he did.
Oh,
yes, we figured that out eventually.
Oh.
Thank you, though.
I'm a little slow. Sorry about that.
No, that's fine. That's fine. There used to be an API by which you could get automatic access to the previous value of a loop variable just by citing, previous var. But they removed it. I remember that now. I don't remember why, but they removed it. Maybe there was an extension and a variation an iterator was using or something silly like that. I've used like 3 or 4 different versions of iterate, so so that's one way you can do it. There's another way, which you may like or hate, but we should try it out.
Okay, I'm with you.
Which is abusing values in short.
Okay, number 2. We're gonna make another one here. All right.
Okay. So just bear with me here. Start with the iterate repeat n.
All right.
Yeah. Now for values x, y in parens.
All right.
Initially, values 0, 1.
Okay, I see. I know where you're doing this. You're trying to do the Python way of doing this. Okay.
then values y
plus xy, right?
Oh, jeez.
collect y.
Collect y. Now this I should have thought of, but this certainly could work. But let's see what happens. There's an error. Hold on. Oh, again. Dang it. I need to stop doing that. Alright. Alright. Let's do that.
You cannot do that with loop, because loop doesn't have a multiple values destructuring pattern, in a sense.
That's my biggest complaint about loop.
Yeah. It is really annoying. I wish loop would let you just do that, but iterate does.
Iterate does, and it looks really. I mean, it looks nice if you can read through it and understand what values it's doing.
If you're comfortable with that style, it looks nice. I've abused that some in some of my code, and in some ways I feel like it's better than the alternative, and in other ways I feel it's much worse.
Certainly, but anybody coming from, say, Python, or even Go. Will know this pattern, right? Because you'll see here and then say, oh, I see what you're doing. You're just doing multiple assignments. You're getting the previous value. You'll know how the execution will work. But, yeah, I could see where it could get unwieldy if someone's, like, trying to be too clever.
Yeah.
But in that case...
I've been way too clever with that particular trick before, using it to set up funky things like finite state machines that involve all kinds of terrible nonsense. I'm not terribly proud of that code, but it ended up being relatively short, so...
Oh, man. All right. Gotta make sure that I...
But anyway, one of my actually personal favorite features of Iterate is how much they extended the finding clause. It's pretty powerful, like finding minimizing or finding maximizing.
So I saw that in the manual, but I never thought. I didn't think of a case where that would be extremely useful, like finding minimizing or finding maximizing. I don't know in what situation.
So let's say you had a list of objects, right?
All right.
And you wanted to find one of the objects such that one of the slots of that object was minimized.
You want to find one of the objects where the slot of that object is minimized. Okay, like let's say,
yes.
Okay.
Well, let's just use like a console to represent the object. So it just has a car and a cooter, and so the simple little pair.
Okay.
Right. Let's say we're storing points, for example. I have actually done this. Let's say you want to find the point let's say you have a list of points, and you want to find the point that's closest to a given other point that you have, right? So what you can do is you can say, for p in points, finding p, minimizing distance from p to, p naught.
Okay, I see what you're doing. You're like doing like a nearest neighbor, or even you can use it to like do clustering as well.
Yes.
Okay.
You can use it to do all kinds of crazy things.
Gotcha. And it will make the code cleaner. That's actually pretty cool.
There's also finding such that, which is the same thing but for like a Boolean predicate.
Yeah, that one, I know about finding such that, and that one sort of I mapped it to, basically like remove if or remove if, well, find if or find if not, if you're
find if or find if not, is probably the best way of describing it. The really interesting thing is that since you can use into, you can actually find both the maxima and minima simultaneously.
So, there's a way of, let's create a little collection here. I'm gonna grab my my random collection. I keep forgetting how to.
Your officially certified random collection.
Yes, I have I have a certified random collection that I was playing around with last time. That I was just like, Actually, let me just write one. It's easier.
This is the random collection. There's no collection more random. Than this
Yes, exactly. No, it was more. Let's see. 4.
For repeat 20, collect random
Yeah.
X.
Repeat 20. Collect. Random.
100.
Let's say X. Okay. Done.
Sure.
So we got this. So now we have our collection.
20 random numbers.
All right.
Hooray.
So we have 20 random numbers, and what we want to do is we want to go through this guy and find the minima
Yes.
of this. So let me just pop.
Find the minimum and the maximum.
Yeah.
Yes.
So let's show our collection, and what we're doing is,
Okay.
is finding x, minimizing.
Actually, that would be much more simply done using just minimize X.
Yeah.
Well, you have to loop over.
4x in. Yeah, that's right. 4x in.
Yes.
Test random collection. Minimize.
Minimize X into min.
Right.
Maximize X into max. Finally, return values min max. Yay.
Return values min and max. Oops.
That might work. I think you need the return. Oh, yes.
You're right. And y is unbound because I am being dumb.
Maximize X.
Yeah.
into
Maximize
max.
x. That's what I did.
Yes. There we go.
Hold on. I have to print it out because I was using compile.
If you use eval, it'll show up in the mini buffer.
Yeah, the mini buffer is kind of small when I do it, so I always print
This
it
is
out
true.
into the console. Hold on.
That's fair.
Okay. Okay, so that's it only printed out the minimum.
Oh, right. Because print only returns. Yeah, do list values min max.
Yeah.
Or sorry, just list min max. Sorry, what am I doing?
Yeah, that's what I thought. I was like, wait a second.
Yeah, much better.
There we go. That's what I was looking for.
Okay.
Yeah, and that actually works. But you were doing finding minimum. Let's do.
So let's pick some number.
Yeah, let's.
Right. Like some number. Pick another random number between out of 1,000 and store it somewhere.
It'll be from 1 to 20. Let's say this. Random index. Yeah, let's say random.
It's not an index. It's a
sorry,
value.
random value. Sorry, that's
Yes.
a good point. Random value. And let's go ahead and do what you. Okay, I see what you're saying. Let's say that we want to do.
Now we want to find the value closest to the random value and the value furthest away.
Right. So we would say print iter for x in random collection, and you say finding x, not such that it was minimizing
Yes.
the expression, right? It's
Yes. Abs of difference between the two.
yeah, minus our random value and x, and I think that's it. That's all I have to do, right? Yeah. Find x minimum.
Yeah.
Yeah. And then find. Could we put this into a variable?
Yes.
Min value. Okay. Finding x. And do the same thing. Just grab this guy. Maximizing to max value. Let's go ahead and do a finally. So that's That's actually pretty cool. So you could certainly use this as I could totally see this being used to simplify clustering algorithms, because you could write it in a single
Yes.
iter loop for writing out your different clustering based on different constraints. That's pretty neat.
Yeah. Basically, anytime you have a property and you want to, find the element that minimizes that property. Ta-da.
So, folks, anybody that's on the call, any questions of what we're displaying here? Like, some of this should be pretty straightforward from the code, but certainly drop a question.
Looks good.
All right.
Iterate is one of those pretty crazy libraries, to be honest. It's crazier than Loop.
The one thing that I want to talk about is def macro clause, where I'm essentially trying to extend it. I was trying to do this example with sum of squares. I think was the example that I was trying to leverage in the documentation. So I was hoping that we can at least touch base on what. So just to give a little bit of a context to folks here that weren't here earlier in the call. Basically, one of the things that Iterate allows you to do is it allows you to define your own extensions, your own aggregations for extending Iterate. Now, if you, of course, make it general enough, you could certainly, and I do encourage you to submit a pull request to add it to the nice utilities, long list of utilities that are available in the library. But documentation does provide you some nice examples of getting into it, and one of them was leveraging this thing called def macro clause. The reason it's a def macro clause is from the documentation, looks like using def macro alone in Iterate, which is what you use to extend Iterate, will actually ignore all of Iterate's underlying machinery. So what def macro clause does, and this is what Iterate provides, it allows you to use some of that underlying machinery. And one of the underlying machinery is this feature that if you don't provide a variable in an into clause, an optional into clause like we did here in this example, Iterate will go and generate a variable for you, or return it from the current form, which is kind of useful. So one thing that I was looking for, and this is what I was trying to do, I think it was expression into, well, you'd have to make an optional var. You can define this guy simply as using existing features that are already in Iterate. So let's say that we're doing sum of squares, but instead of summing individual x's, we'll do, x per. Now, I'm not, this may not be hygienic to most folks, but I'm using this for sake of example. I could certainly make it hygienic. Well, that at least do like accidental name capture by using with Jensen's or whatever, but I'm going to ignore that for a minute just to get this example in. You could write your clause this way, right? And what it should do is you could then, once you've defined it, which, as you can see, Elijah, one issue that it was saying is the extension in this guy, this template here, this optional thing, is straight up from the documentation, actually. This is why I wanted to talk to you about this, if you had more experience on this. Because I think it's a point of good discussion to talk about some of the things that are in the documentation that don't necessarily compile you expected.
You want to give, if you're using def macro clause, you can't just say optional var. You need to give it a keyword.
Like into like this?
Yes.
Okay, that does it. Because originally I had it like this, and it kept complaining. I was like, this is exactly right. I'm sure of it.
Yeah, that ought to be fine.
Well, I guess it was complaining about something else. Then when I did this earlier, it didn't necessarily work. So let's try this. Iterate for I for x from 0 to 10. Sum of squares x. That works. That's cool. All right. So I'm betting you what happened was it was a name conflict, and since we now have this in an isolated package, I'm not having that issue before. I just didn't notice that was the error because I was having some issues.
Something like that, probably.
Yeah. Okay. So you can certainly see this, guys, where you can not only create extensions like this, you can also use it to create, and this is another feature that of Iterate that I personally like, to write generators. You can actually use Iterate to actually write generators. So it's a single package that gives you the ability to write generators as well as deal with iteration. Now, there is another package that I've used before in the past called generator that'll give you Python-like generators. So those of you who are familiar with like yield and stuff, it gives you like yield. So it makes it easier to create generators like that. I'll touch base on that in a different thing, but I want to mention it here since I brought up the topic of generators. Uh-oh. Okay,
yeah,
I hear.
We probably want to talk about that sometime.
Yeah.
Yes.
Yes. There is. So it sounds like you're not too thrilled about that library. So we certainly.
Oh, I like it. I think it's a really cool library. I don't use it anymore.
Excellent. Good to know.
It's so that just quick, very lightweight overview. That library makes use of something. It makes use of another library called CL Cont, which does this funny thing called continuation passing style transformation, which is really useful because it lets you implement your own control structures very cleanly using continuations, which is how they're able to make generators like that. However, it is a code walker, and not only is it a code walker, it generates a lot of code that SBCL can optimize away. But when you mix continuations with a code walker like Iterate, what you end up with is any non-trivial function takes a good 10 seconds to compile.
Wow, that's
because it generates just so much extra stuff, so that you have the ability to pull the kind of trickery that you get with Python generator style things. It all gets optimized away. It generates very efficient code because actually SBCL internally is using something like continuation passing style transformation anyway as part of its own optimizations. And so the fact that you're doing it at the macro level just means that you have the ability to manipulate it at that level. It doesn't actually slow it down because SBCL is already going to go through that process to do its optimization stuff. But SBCL, takes a while to process all of the code that thing generates. And so if you're not careful, you end up with really slowing down your live coding experience. And so I just sort of stepped away from it. I just, stopped using it for things unless I felt it was really the tool for the job, and it rarely actually was.
So in Iterate, at least, you have this function called generate or generating, depending upon what your library to do, and you can extend it, guys. So not only like what we did before with the summing and all the stuff, you can certainly use generate to actually do generations, and it does a nice. Why didn't this actually do what I needed it to? Collecting X into col. It should have worked. Oh, next X.
Next.
Damn it. All right.
X.
Yeah. I'm sorry. Yeah.
That is in fact the whole point of.
Yeah. Oh wait, no, I know
interesting.
why. I know. Finally, I think I have to return the collection.
Return call.
Yeah.
Yeah. Or you could just not use the into.
I was actually, since I'm using a generator, I have to use the into because otherwise it loops. Yeah, it loops forever. I know that for I was playing around with this and I came up with this example that actually where and I can show you guys this just so that and then I'll kill.
Okay.
It's if you do generate x up from 0 and you do collecting x. If I do two,
that will break, definitely.
Yeah, if I do this.
If you have the until in there, it should be fine.
Up until this. Until, and then what is it going to be?
That's a good point. You can't give the length of that, can you?
Yeah, you can't.
Fair enough.
So,
got it. I'm good now.
So this here. Let's go through this piece of code. This is much like what I was showing you earlier with loop and up from. This up from starting point and no ending point creates what's called an infinite sequence. So it'll just keep on. But what generate does is, much like generators in other languages like Python and so forth, it yields and waits until you call next on the generator. So it creates an object that behind the scenes essentially is invoking a computation that's only invoked and run when that next is called. So what this guy does in each time when you do up from 0 is it creates an object that increments x. So it'll return, if you call next x, the first value it'll get is 0, and then it'll stop the computation, and then we call next again, it goes 1, and so on. So this is very useful for cases where, especially, this is a contrived example where we're creating an infinite sequence and collection, but where generators, at least I've used it in these cases, becomes very useful is when you're like retrieving something from a socket and you want to, I actually take that stream socket and make a generator on it so I could just say, if there's nothing next on it, just go ahead and, give me a nil, so that way, or bind it to a variable and then do some execution on it. That's where I use generators. There are other ways of handling that too, especially with the stream APIs and so on. But it's certainly one example where generators becomes kind of useful. Also, if you're dealing with like infinite sequences, like in the Haskell sense, where you're trying to take 10 values from an infinite sequence, that's where it's also kind of useful too as well.
Or closure.
Or closure. Yeah.
Yeah, that's actually what I was going to ask. Is there any difference between this and a lazy sequence, or is that just basically the same thing?
Well, so the difference is that at runtime there is actually no object. Just to slightly correct you there, with iterate specifically, iterate doesn't actually create any object. What it actually does is it changes. Next is. You can sort of think of it like a macro, kind of, but it's actually just a bit of magic inside of Iterate's code walker, and it gets replaced with the proper code to increment the variable before returning it. And it just figures out what the right code to do that is because it knows how to step the value for x, and so it just sets it up so that when you say next on that variable, it just replaces that with the code to increment x. And so while it's sort of like a lazy sequence, you can use it like a lazy sequence. There is actually no runtime object that's tracking that lazy sequence, really. It's entirely inlined, I guess you could say.
Yeah, so it's like a statically optimized lazy sequence,
kind of.
And it's pretty useful in the same situations that lazy sequences are used. I personally have not seen it used in that situation, though. That's maybe. Have you seen people use generators in that use case, Elijah, and other code bases that you've seen?
I mean, I've seen it a little. I've used generate as well. in similar ways. I don't remember offhand, though, terribly well. It's been a little while since I've done anything serious with Iterate, so
Okay.
I remember a lot of the API. I don't remember a lot of the usage.
Okay. Any other questions? I see we have a new Sergey. Do you have any questions?
Hello?
Hello. I'm sorry, Sergey. We can't hear you.
Oof.
Sergi,
No, Sergey. Sorry.
I'm fine. Just listening to you.
Okay.
The only other question I have, Ram, is and I think I sort of asked this last week, but then I don't quite have a handle on it, and I don't know if somebody here can maybe illuminate it further. But I'm still a little confused, and I guess it brought it up with Iterate even more. Like when the loop macro runs, and you use like the keywords like for and whatever, and same thing with Iterate, and it's turning them in the package that you're in, or you could use like the keyword package. Like what exactly is happening inside that macro?
Well, Iterate uses its own symbols. It doesn't see what loop does is it doesn't care what package the symbol is in. It only looks at the symbol name. Okay, what that means is you could actually call.
You could use different packages with each of the different loop keywords if you wanted to. You could generate a new package every time and use a different package for every single one of your loop keywords.
You could package qualify for if you wanted to with your own package.
Yeah.
It would be perfectly fine. It doesn't have to be your symbol. It doesn't have to be loop symbol. It could be any symbol you want.
Yeah. Whereas Iterate, on the other hand, it has to be iterates for, because Iterate does actually care. Iterate does not look by symbol name, and that's partly because Iterate expects you to be sticking the iterate clauses in arbitrary nested Lisp code. There's a nice little example we could do of that real fast, Ram, if you don't mind.
Sure.
Where it's like the difference, like let's say you had a list and you wanted to collect all of the even things in the list. You had a list of numbers and you wanted to collect all the even numbers,
All right?
If you want to do that in loop, you have to have put the if using the loop if driver in a sense, the loop if keyword, right? 0 to 20. Whatever.
Yeah, that's what I'm doing that, and I do when. Yeah. You can do when or if. I guess.
Yeah. Either way.
Yeah, when even p. And then you can do collect.
Collect I. Yeah.
Collect I. And this guy, if you look at it,
and I'll change the keyword when to com.rv.demo : when.
Or something along those lines, or just
don't
use
colon or anything.
Yeah. You probably have to use 2 colons because otherwise it'll tell you it's not an exported symbol.
Well, I have to first export. I don't have a when exported in my demo.
Right.
Oh, right.
That's fine. That's why we're using double colon.
Oh yeah, that's right. Okay. And it works the same.
It doesn't care what package it's in. It's only looking at the name. If you recall back to when we talked about symbols, symbols have like 5 properties on them: name, value, package, etc. It's only looking at the name. It doesn't care where the symbols came from.
Most things in Lisp care about the symbol's identity in a sense. It's equality based on EQ. Loop does not act that way. It's unusual in this respect that it looks specifically actually at the name of the symbol. But the other thing is the reason why iterate actually requires you to use package qualified ones is if we rewrite that using iterate, you would actually use common Lisp's if or common Lisp's when. Do that on like a separate line. Show both.
Yeah. Iter
for I.
Yeah.
You can use colon for that if you want to, or you can not. Your choice.
Yeah.
But yeah, you can just say, you can just use Lisp's, stuff, and then inside of that, you can stick the iterate collect form, right? And that only works, like, at all because iterate it has a code walker. It actually steps through all of the sub components of that code.
So
Walks through them, figures out what's in there, and because of that, it actually it's good that iterate is a bit more discriminating about when it detects that you've used an iterate clause.
So
Because if we're going
I think the confusion comes from the fact that when we talk about code walker, we literally mean like it's a parser, right? It's a macro.
Yeah.
It's expanding a macro. Iterate is a macro that expands itself, takes all the forms that it sees, and it generates what ultimately would be.
Yeah, it basically like so CodeWalker. What that really means is it goes to every single subform that it receives, and instead of just using them, treating them as just like black box expressions, constructing something that makes use of them and returning that, it actually expands the macros in those sub expressions on the spot, on its own. It actively expands those, and then it steps into those sub expressions and goes, "Oh, what is this thing? Oh, it's an if. All right, I'll step down the three branches, the three parts of the if, right? And then I'll, macro expand those, and and it keeps going through every single sub expressions to see if it finds something that it recognizes an iterate clause, which is actually kind of how best to put this, fragile. Common Lisp isn't actually designed to make code walking terribly easy. You're really it works, it gets the job done, but apart from situations where I'm the entire point of the program is to use a code walker, I tend to avoid them nowadays because there's no guarantee that they'll always work perfectly. Because they have to handle a lot of edge cases, and technically speaking, the list of edge cases they have to handle isn't set in stone. So,
So how does that differ from what Loop is doing?
If you inspect Ram, if you inspect in your repo the symbol for iter : collecting, I'll just give an example here.
Okay. But I think it's
Inspect the symbol so we can look at this, all the symbol properties. Okay. That actually, Loop is unique in that it uses the symbol name. Okay. Iterate is actually unique in that for its synonyms, it uses symbol property lists.
Should be there. Okay, there we go. So.
Oh wow, it does. I never noticed that. That hurts me inside.
Yeah, so they both use symbols in a very unique way, but very different ways.
I hate that.
So Iterate uses symbol property lists.
I hate that.
It uses. This is the first use case of property list that I've.
What Loop would do is it would only look at, you see the first one there, 0, name, collecting. It would only look at that. It wouldn't care about the package. Iterate cares that the package is iterate. It has to be iterate. Loop does not care about that.
Technically, no. Technically, iterate doesn't care about the package or the name at all. It cares that it's the same symbol as one that it's already seen, I guess you could say. But the only way that you could get a symbol that's the same as the one it's already seen is if you use the iterate package. Because that's how it got that symbol. Right? My point is that the package is already handled well before iterate gets a chance to look at the symbol. It could inspect that explicitly if it really wanted to, but it has no need to. Does that answer your question at all?
Yeah, sort of. I mean, I'm probably gonna have to at some point.
Loop's just using symbols in a very unique way.
Yeah.
Not many libraries do that. Just look at the symbol name of things. It's just unique in its own way. There's really no other way to explain it because I can't compare it with any other libraries.
Yeah, I think initially, like last week, I was more confused, like why when you use the symbol inside Loop, how come like it started I guess, contaminating the package you were in. But now I guess it's just because, right, that symbol is being interned just because you're using it.
Right.
And loop
Right.
doesn't really, it has
Right.
nothing to do with what loop is doing internally.
Correct.
It just happens to be that symbol.
So loop, a lot of the keywords in loop are already interned in the keywords package. As far as
Yeah, because other people have been using loop already.
right,
And just pretty much most, I would say probably the majority of Lispers these days use keywords for loop keywords. Use keyword symbols for their loop keywords. In my experience, the majority do. And so a lot of them already are in the keyword package.
so that's a reason. That's another reason why the colon. I mean, I prefer the colon form than a lot of existing code that leverages the non-colon form, because you're aware just by looking at the code. Essentially,
And Mike, that's the only reason why keyword symbols work in loop, is because it doesn't care about the package.
Yeah.
Right. Yeah. No, yeah, it makes more sense now. No, I think that was what was confusing me last week. It's like, because it's like, oh, they're keyword symbols, but like even though they're keyword symbols, right, they're totally different looking. So I couldn't figure out like how when they were programming loop, how it was able to just distinguish regardless of the package, or if it was even a keyword symbol.
Yeah. No, it just
looking at the name.
Yeah, it just looks at the name.
It just looks at the name, string comparison, essentially.
Yeah, no, literally, it literally does. It literally does a string equal.
Yeah.
Because symbols are actually string designators, so you can pass them to string comparison functions directly, and it'll compare them by name. Fun fact.
Excellent. Good to know.
One that I've used more than once.
Yeah.
There is. Sergey, did you make a comment? I didn't hear that.
Yeah, he said.
Yeah. The thing about symbols being strings, and you can pass them to string comparison functions.
Yeah. Okay. Gotcha. All right. No, it's interesting. There's a lot of these little quirks that you end up picking up just as you keep on developing more and more into Common Lisp. Well, it looks like I won't be able to touch on 4, but just very quickly, guys, I'm going to just give a brief summary on 4, because 4 is essentially the same idea as Iterate. It certainly improved on it. It has an example that I want to essentially illustrate a little bit more, but I'll wait until next time on this. And that is, it implements something called the Iterate. It has an iterator protocol that is built in, and that's how you would use. That's how you would extend. That's one way to extend 4, so you can iterate through your own user-defined collections. There's a couple of other things related to the macro example that we had here with sum of squares that I haven't had a chance to really touch base around and play around, so I don't want to demo it without a little bit more battle testing from my end. Otherwise, it's going to be a massive demo fail, and a lot of confusion is going to induce from it. So I'd rather not show it off. But are there any comments on Iterate alone? Like 4 has some improvements on this, but in general, this idea of extensibility from Iterate essentially follows in with 4 with certain with a different approach behind the scenes.
Yeah, so Iterate's main selling points are, number 1, extensibility.
Yes.
And number 2, being able to split up clauses into arbitrary forms.
Right.
The latter you definitely can't do with 4. I don't know about the former.
Yeah, you can't put 4's clauses in arbitrary Lisp subforms because it's not a code walker.
Right. Okay then. Next time we will. I'm gonna see if I can get a. I was playing around with the live chat protocol earlier today.
Interesting.
The live chat protocol, for those of you who aren't familiar, and let me just go ahead and change it. Change to that. Give me a second. It's from the same guy who wrote the 4 library. Give me just a second so I can share my screen here. This guy. Okay. So, and just give me 1 second so that the folks on the live stream can actually take a look at it too. So the live chat protocol is a protocol that implements essentially a two-way communication for a chat system. And Shirakumo, which is the collective that Shinmura is part of, the guy who wrote the 4 library. They've actually wrote some a web version of this using WebSockets, like a chat protocol and chat client using WebSockets as well. And I was thinking that a good project for us to start and at least discuss is how to implement a chat client using LiChat. Because in this this project, you will learn how to use like sockets, how to create a simple socket server, how to do things with exceptions, what kind of conditions should we actually have to work through, and if we can get a server up and running, I can also start talking to you guys about deploying the sucker on, say, a Docker container, and run it either on your own Docker instance or even on, say, AWS using ECS. So, but that's hopefully I can get that in before the next time. Which brings me to my second announcement. Next week, the Atlanta Functional Programming Meetup is going to be hosting an event here at Georgia Tech. And because of that, it's happening on Tuesday, June 5th, we will have to postpone our next study group to the week after. I apologize for folks who have been coming very diligently every week. I do appreciate those guys. I hope this is like the highlight of my week when I study with you guys on doing some of these Lisp things. So let's meet up after the 5th, which is, I think, if I look at my calendar, we'll be back on the 12th, all right, the 12th of June. So until the 12th of June, we're having an off week. I do apologize for folks, but then we're going to get started on doing a real project. If you guys have project ideas or deployment questions or anything like that, feel free to send me an email. I'm on the Functional Programming Slack channel. I'm also on the Discord server periodically. But you could also find me on Twitter too as well. I'm Unix Nerd on Twitter, and I'll post that also, just so that folks of you who are actually looking to say, hey Ram, AFP CL study group should study this or look into this. We'll take those feedbacks under advisement and put those into our study groups in timely fashion, as timely of a fashion as we can. So this is my Twitter handle. If you're on functionalprogramming.slack, I'm Bugram on functionalprogramming.slack. So feel free to DM me if you have questions. Any other comments? Cool. Till next time, folks. Thanks a lot for joining me. Sorry we had some technical difficulties early on, but hopefully all that got squared away.
All right.
See you guys.
Bye then.
Thank you. Good discussion.
Thank you.